Let's compare irrational numbers. When I say compare, we're talking about like greater than, less than, less than, greater than, equal to, that sort of thing. All right, so first let's talk about what is an irrational number. Well, sometimes it's easier to say, well, what is a rational number? And then we can go the opposite. So a rational number can be written as a fraction, meaning we can write any number as a ratio where the bottom number is not 0. Obviously, because if the bottom number is 0, it's undefined and that doesn't work. So when you think about what can be written as a fraction, and that, anything. So 3/4, 1/3. Even though 1/3 is a repeating, right? If we change this, it becomes a repeating decimal, that's fine. So terminating or repeating decimals. That's basically the idea. If a fraction can be turned into a terminating or repeating decimal, we are fine. So an irrational number, that means irrational cannot be written as a fraction, which is fine. So we're talking about like square root of 3, any square root that is not perfect. We can talk about pi, which we know is 3.14. We can talk about e, which is 2.71. Those kind of numbers that just, and those go on forever. I stopped at 2 decimal places, but they go on forever. So let's go ahead and compare. Now, if you have a calculator, you can punch these in, compare the decimal approximations, and go from there. But we're going to pretend we do not have a calculator. So with pi, hopefully you have an idea with pi that it is approximately 3.14, right? That's kind of a famous irrational number. Most people know decimal approximation for pi. That's great. And then we get to square root of 5, and I'm like, well, I don't really know. So let's know, what do we know about square roots? Well, I know the square root of 4 is the same as 2, and the next perfect square is 9, so the square root of 9 is 3. So that means the square root of 5 falls between those. Now, it's closer to 4 than it is to 9, so it's going to be somewhere between 2 and 3, closer to 2. So it's going to be 2 point something. And if we just compare that, we know that pi starts with a 3, the square root of 5 starts with a 2, so pi is greater than the square root of 5. And if you use a calculator, you will find out the square root of 5 is approximately 2.236, and it goes on. Okay, but pi is greater than the square root of 5. Okay, let's go on. Let's do one more. Now we're going to compare the following numbers using inequality symbols. We're going to compare 8 square roots of 2 and the square root of 19. Now this one is just a little bit trickier because we have this 8 square root of 2. Now this is the same as thinking 8 times the square root of 2. It's the same basic idea. And what do we know about the square root of 2? Well, the square root of 1 is 1, and the square root of 4 is 2. That means the square root of 2 is somewhere between 1 and 2. We could estimate, it doesn't really matter, but let's just say, okay, it's going to be somewhere between 1 and 2. That means if I multiply by 8, 8 square roots of 2 is going to be somewhere between 8 and 16, right? My answer is going to be somewhere in here, and because the square root of 2 is, closer to square root of 1, it's probably going to be on this side, right? So 12 or under. But somewhere between 8 and 16. Let's just start with that idea. Now we go to the square root of 19 and say, okay, I don't know what that is, but I know the square root of 16 is 4. And the next one up is square root of 25, which is 5. So that means the square root of 19 is somewhere in the middle, which means the square root of 19 is between 4 and 5. Now just compare that. If we say somewhere between 8 and 16, meaning the smallest it could be would be 8. And that's if it was just 1, but we know it's bigger than that. Here on this side, comparing, between 4 and 5, that means the largest it could be is 5. And we know it's not 5 because it's not the square root of 25, which means it's going to be smaller than 5. So when we compare 8 square roots of 2 to the square root of 19, we can see that 8 square root of 2 is going to be bigger because 8 is bigger than 5. And that's just with estimating. So again, if we would use a calculator, 8 square roots of 2 is approximately 11.31, and the square root of 19 is 4.358. So you can see clearly that 8 square roots of 2 is bigger. But again, if you don't have a calculator, you can use what you do know to compare and use what you do know. Use your context clues and the numbers you're given to move forward with those.